Okay, so on this video, I want to show you something that I wanted to do for a long time. And this is to have one particular problem and see how many different AnyLogic developers would solve it with their own styles. So I have 7 different people, and I will show the models they did. And at the end of the video, I will show what model I did. So I will introduce each one of these people as I show their models. So let's get started with this. Okay, so everybody had the same rules for this game. Everybody had only 3 hours to complete the model, and they were not allowed to ask questions, and they had to make their own assumptions and interpret the description of the problem however they see fit. So the first thing I'm going to do is explain what the problem is and what are the traps that you can see in there. Okay, so let's go with that. Okay, so here is the description that everybody got. And it's kind of an easy idea where you have a queue of people that go through a scan or a scanner in the airport. And after the scanner, they are searched by different security guards. And you have different parameters that you can use, for example, input rate, scan time, alarm rate, etc. So one of the things that is interesting here, what you have to take into consideration, is that the passenger input rate has an average and a standard deviation, which makes you believe that you should use a normal distribution. But you can't really use a normal distribution for rates, so we will see how people do that. Then you have certain rules that define what happens if someone fails the scan or passes it. And then you have certain rules that allow only certain people to be searched by certain security guards. So females can only be searched by female guards, males can only be searched by male guards, and you have a female guard that is specially in the management of the scanner. So this person cannot scan and search at the same time. Whenever there's no space in the security guard's area or there's no resource available, people have to wait in the scanner until someone is free. So this is the general idea. You have 3 configurations that this client wanted to test. So with 4 security guards, 3 security guards, and 2 security guards, and see the differences. The intent here is to have an output which is based on the scan time, the search time, and the staff numbers, an alarm rate. What is the output on throughput capacity that you get? So how many people go through the system per hour or every 5 minutes. And then you want to run a significant number of simulations, so that means that you need the ability to do Monte Carlo simulations. So this is the whole problem. So what we want to measure here in each one of these models is are you able in the model to change the parameters? Second, does the model do what it's intended to do? Is it modeled correctly? Another thing is everything hard-coded or is it flexible? Can you run the different configurations that are portrayed in the problem easily or not? Do you show the throughput output in graphs or any number output? Can you do a Monte Carlo? That's something else. And another one is, are you using this normal distribution for the source or how you generate agents arrival time? And the last thing is, am I being informed about all the assumptions they made or not? So let's go and get started with the first model. So this first model was made by one of the candidates of the simulation engineer position that I offered last month. So he did this. Like, the animation in general looks pretty nice, but this is an image, so it was probably taken from somewhere, I don't know, but it's pretty nice at least. But it seems that he spent a lot of time making things nice while not taking into account a lot what happens in the model. So what you see here is a generated passenger who goes to security and may fail the scan or not, and then goes out. In here, there's not even a resource that was used. So the model is quite incomplete, and he made a mistake of using a normal distribution here. Like, we want to explain that when you use normal distribution here, you're just generating one sample of the normal distribution. So for example, in here, the normal sample will be 9, and then that means that you have an arrival rate that follows a Poisson distribution with average 9. So that's why this is a mistake. So this is the model that we have. She chose to use the pedestrian library, but nothing was done in terms of the rules. There's no parameters, no user interface or anything. So most of the time was spent just making things nice. So this model was made also by one of the candidates for the simulation engineering position. And we see an animation here, but it's difficult to see what's going on. Like, you have this in 2D, but you also have the version in 3D where people are submerged in the sea. But it's difficult to see what's really happening. So the simulation animation is not very good to validate at all. But he chose to use the pedestrian library. So let's go through the different points. He used the normal distribution, and also he hard-coded everything. So there's nothing that is defined as parameters. And this is something that generally you want to know, that when you say, hey, you left hard-coded values everywhere, normally what people answer back is that, hey, no, I did it because I wanted to do it fast, and I'm going to change it later. But the thing is that you forget to change it later. So it's always important to put variables or parameters immediately while you're building the model, so you don't forget anything. So that's one thing. One of the difficult parts of this model was that FM as a resource was in charge of search females as a second option after F1, and also for the scanner. If you have two scanners, you will need FM to handle the two scanners, but since you're using the pedestrian library, it's difficult to do that. And it's not done, that part is ignored here. So also something important is that he did two scanners, but he copy-pasted the top and the bottom. So I don't know why he did that, but in general, when you're making a model that has similar parts, you want to create your own flowchart block, and then this flowchart will have certain parameters that you can change, so you have two of these blocks. And that way, the model will be more robust. Another thing that is weird that he does is using the log normal, and there's no information about using the log normal anywhere in the description. Okay, let's go with the new model. This was made by Akil, which is the only level 2 Fiverr freelancer that has AnyLogic experience. So this is what he did in the 3 hours that he had. So it's nice to have an animation just to be able to validate, even though you can differentiate between men and women. And on that regard, we're going to use this model to see something that is very, very important as a foundational thing that people want to learn. The triangular distribution, which is basically the same problem as using as normal distribution. You shouldn't do it. But anyways, let's see what he does here. In the source, he uses this setup passengers function, and this function has this code, which means that each pedestrian or passenger has a male variable and a female variable, and it calculates both. So that means that each passenger can be female and male at the same time, and also neither of these options. And maybe he did this quick because, of course, everybody is under time pressure, so it's normal to make mistakes. But the problem occurs here. You have this select output that asks, is it a male or is it a female? And the condition 3 in here, he uses true. So this is something that a lot of people do that make them kind of solve a problem without solving it. So probably he was running the model and he saw that it was throwing an error because female and male were false, which is totally possible because both of them can be false in the beginning when they are created. And then he created this sink in order to eliminate the problem. And of course, this is fast done, but in general, if you do that, which is very often people do it, this will be found during the validation phase if you do the validation phase properly. So an interesting thing here is that he doesn't use resources. Instead, he uses directly delays with a capacity of 1, which is totally okay. You can do that perfectly fine, as long as you have a good rule that makes the person the capacity plus the capacity of FM and the capacity of the scanner equal to 1 as a sum. Because remember that FM is in charge of searching and the scanner at the same time. So he tried to do it, but he said when he delivered the project that he didn't manage to do it in time. So this is the simulation that we got from Akil. Okay, let's go with another of the models that we had, also using the pedestrian library from a Fiverr freelancer who wanted to stay anonymous. So here at least you have a differentiation between men and women that you can see here. This is very important for validation purposes. And you can see the model here that has a lot of good aspects. And in particular, let's run the simulation fast. You see that there are some movements that allow you to make things more understandable, right? So that's good. Another thing that is important is for the first time we see someone that wants to do the Monte Carlo experiment. So if we see this, he creates a plot and he inserts this into a database. So if you run the parameter variation experiment, you will see the results in here. Now, he didn't send me the documentation of this, so I'm not sure if it saves all the time or what. I don't want to analyze that, but at least there's a good attempt to do it and you get some results. So again, in the pet source, we see the arrival rate as a normal distribution. Same thing that everybody had. He makes another little mistake that a lot of people do is, for example, when you have a delay time and you see that the search time is actually a distribution, that means that you will be able to sample the distribution only once and everybody will have the exact same search time forever. Like all the passengers will have the same. So you don't want to do that in parameters unless you want to calculate it only one time. Okay, so this little model here was made by someone who had made their master in agent-based, and this was the first time they were facing a discrete events problem, so they did this in the 3 assigned hours just by looking at the help documentation. And in fact, here you see very little issues and almost all the things required in the model are there. So here the only problem is this triangular distribution that you have as the arrival rate, which is wrong, but the rest is quite good. even though it's quite a minimalistic project, it has everything that it needs to have. Even though it has maybe this unnecessary queue, but there are no like horrible errors here. Okay, now we have the model of Jaco, who is one of the founders of the AnyLogic modeler. He has a lot of blogs and tutorials everywhere. And he uses a library here called the Material Design Library that you can actually purchase if you want to make nicer models and have these templates for tables and buttons and stuff. So you can investigate that, and we see his simulation here, and for the first time we see a user interface where you can actually change the parameters in the model and test it. And one of the things that he does here, which is quite advanced and is very nice, is that within the same simulation model, you can do a single run, right? And see the simulation model where you see the at least an animation that has the resources and the edges moving. We'll analyze this a bit later. But what you also have is the ability in the same setup to make Monte Carlo simulations. So here we'll call this scenario 1, and we want to do, for example, 6 repetitions, and this guy is going to run the simulation 6 times and show you the outputs. So this is quite amazing because it's something I never saw before, that you have the ability to run using the custom experiment, running simulations within the experiment, the normal experiment, which is quite cool. So this is quite an advanced feature. And you also, important, you can have a table here. You know that in AnyLogic, creating tables is such a pain in the ass, but thanks to his library, you can just create tables very easily. So this is a pretty nice feature of the library, because yeah, tables are hard. Now he was the closest of everybody to finish the whole thing. So let's see the model that he did. Unfortunately, in the source, he committed the same mistake that everybody commits. This is the normal distribution here. That's unfortunate, and maybe another problem he had is that he forgot to write the parameters here, so this ended up being hard-coded. So, but in general, besides that, this is quite a good model, and you have the Monte Carlo simulation, and you have everything you need. So the only thing that he needed a little bit more time to do is just to validate what he did. So of course there was no particular description in the requirements to build any animation at all, but validations but animations are great to validate your model. Okay, now it's time for my own creation. Let's see what I did in these 3 hours. So you see here you have a nice user interface. You can select the 3 scenarios that existed here, and you can define the simulation length and all the elements. And in here, in the arrival rate, I don't use the standard deviation because I'm using Poisson distribution, as everybody should have done. So if you start the simulation, you see this nice simulation here. The cool thing here is that I use a trick to make the queues nicer, that is just using a container. So here the movements are all identified, the movements are complete, you can see that, and I added colors in order to make the simulation prettier. So also you have the graphs here that define the passengers every 5 minutes, the metrics, and all that I use in particular to validate my model, and also because it was part of the requirements that were requested. So You can see my model here with all the movements and stuff. And here I just use the Poisson distribution. So I just want to know the error rate per minute, and that's all I need. So the assumption here is that the normal distribution was a mistake, and instead you should use Poisson distribution. So during these 3 hours, the only thing I would say that could have done be better in my model is to have this not hard-coded. I just hard-coded the probability for a person to be a man or a woman. And instead, I should have added this into the configuration parameters, but I didn't. So this is what was missing from my side. And also, I didn't do the Monte Carlo simulation in the 3 hours. So I needed 1 additional hour to do a Monte Carlo simulation. I just did it and exported the values to Excel. And you can see the export file here, where you see all the inputs and the outputs, and nicely formatted for the client to analyze. So I give the raw data of the results, not the raw data, but the raw results, basically, without my own analysis. So, but this was done after the 3 hours. So it was done, I think, between 30 and 45 minutes of time additionally. So this was pretty fun to do. And besides the critiques of the model that I do with an educational purpose, it's very interesting to see that everybody who tackled this problem did it in a completely different way, having a completely different concept on how to tackle the problem, even though the ideas of it are very simple. So I was expecting to see very similar models, but that was not the case. Another thing that is interesting is to see how different people have different priorities. In my case, my priority was first to validate, next to make something that is pretty, and at the end, do this parameter variation experiment that I didn't even have time to do it in 3 hours. On the other hand, Jaco his purpose was to do the functionality that was more complex, which was this Monte Carlo experiment within the simulation, and validate later. So he didn't spend time on validation and instead on functionalities. So others were trying to do a mix of these things. It's difficult to validate a model though, and in particular when you have very little time. So this is it for now, and see you on the next one.